Right, before we get started, anyone who's not seen me talk before, I tend to swear now and again. And if you... And that's just because I'm Glaswegian. And ultimately, I have my own rating for these talks. So my rating is NSFW Glaswegian because I swear a lot. Now, when I'm swearing, I'm not swearing to offend anyone in the audience. So if anyone feels offence, that's not me trying to make you offended. Unless you're being a cunt. Then... Oh yeah, that's the other thing. Every time I swear, these people are going to fucking pom-pom. So the recording's going to be shit. So yeah, this is Archaic Creativity, pulling at infinite threads. Essentially, when I submit talks to CFPs, I give them stupid titles, and then about a week before the conference, I go to the organisers, what did I submit to you guys? What the fuck did I submit to you guys? And they go, here's the blurb, write a talk. So yeah, and then about 20 minutes ago, I logged into my laptop and I was like, where are my slides? My slides are not on this laptop. But it's fine, we've got them, so it'll be all good. And then about 20 seconds ago, HDMI wasn't working. But we're here. So today I'm going to talk to you about Windows environments. We're going to talk to you about how to blend into Windows environments and a lot of the problems that people who work in the red team sphere and people who work in the blue team sphere observe with Windows environments. I'm going to start off by shitting on what I do as a job. That's going to get really fucking annoying. Essentially, I work as a red teamer. Red teaming is what I do as a day job, but one of the kind of fundamental problems with red teams is that they are overly reliant upon command and control infrastructure like C2. They're overly reliant upon malware. They're overly reliant upon just executing stuff that isn't meant to kind of execute in said environment. Yes, you have loaders. Yes, you have things that blend into binaries, but a lot of the time it's bringing an unknown or alien binary into an environment, executing it. And yes, you might get past EDR XYZ, but ultimately getting initial execution isn't the goal. Actions and objectives is. And a lot of the time, EDR products, they might let you get initial execution, but it's when you go to do the action is when they start to kick in. One of the other problems with red teams is a lot of people who work in the offensive security sphere don't really understand how the defensive security element of things work. And what I'm going to try and cut across in this talk is understanding Windows environments, having a look at your environment. So this is just a screenshot I pulled off Google. I was going to pull it from my lab, but there's a lot of stuff running in my lab that's maybe not relevant to this talk specifically. But essentially, this is a process tree. This process tree shows the child processes of different processes. On this, we've got WinInit, that spawns services, that spawns SVC host. I'm going to talk about SVC host later on, but essentially SVC host is probably the most noisy, it's probably the most noisy process on a Windows operating system nowadays because it launches every service. And as a result of that, it's a very good process to blend into and execute from. So, quick bit of background of defensive evolution. So, defense back in 2010s, back in the early 2000s, was very much signature based. So you had like antivirus that was very much, you had a hash of like malware and these kind of things. And if you had adware, malware, potentially unwanted programs, all that sort of stuff, then you'd be caught based on hashes. And once it was known bad, it would be marked as malware and then be marked as malicious. Nowadays, not just 2026, it's probably the last 15 years, it's gone to behavior based. So much around what the parent-child relationship is of what you're executing, what the authentication patterns are. So if you're running a binary that is otherwise benign, but for some reason you're running as an admin, and EDR or defensive tooling will flag up on that because there's elevation of privilege there, which is potentially irrelevant to what you're doing. Network behavior is also another one. So there's lots of research in the last couple of years, probably the last 5 or so years, into command and control infrastructure. So there's been tools for like parsing Cobalt Strike beacons. There's been tools for carving out like Havoc beacons, lots of different C2 tools and pulling out the config file from those, like that shellcode. And that falls under the kind of network behavior because a lot of the time you can spot C2 traffic if you look at like network deltas. Because C2, for anyone who's not aware, operates on like a beaconing basis. So it's not, most of the time it's not interactive access. It'll have like maybe a 10-second call in between requests, or maybe there'll be jitter between requests where it's like 10 seconds and then maybe 10% on top of that or 20% or whatever. And then you send your next command. And if you look at that in network logs, you can see that there's a spike in traffic or maybe there's a small blip that you can start to behavioral profile things. And then finally, you've got user behavior, which is probably the hardest to spot because anyone who's worked in sysadmin or even defense in the room will understand that users a lot of the time will do things that look really fucking suspicious, but as a result, it might be normal behavior, and these all lead to kind of the binary often matters less than the behavior. So this introduces my methodology. I can't walk away from the lectern because the microphone is there. And that's for the video recording.
You're loud, we can hear you.
Yeah, it's more for this thing. For people that want to...
Oh, sorry.
Anyway, yeah, so Saskia's going to be the recording. So, yeah, this is my methodology of build, break, defend, fix. And when I write blog posts, I've written a course, I've written a bunch of stuff. You can buy my course, it's £349. This isn't a sales pitch, but, it's fine. It's about blending into Windows environments and doing shit. The build, break, defend, fix methodology is about understanding environments from all the different avenues and elements before you start to do whatever stage of the process. Because I think it's really important, if you're going to break an environment, if you can understand how that environment is put together, you can understand better how to break it. And ultimately, from a defense perspective, if you understand how it's built, how it can be broken, you understand how to defend against it. And then finally, you also need to understand how to fix these things, because anyone who's doing offensive security nowadays, unless you're doing crime, is doing it for defense. It's doing it to improve things. So you need to understand how the bugs and the gaps and the misconfigurations you identify in environments can be patched, and can be patched effectively. Because if you're recommending to a client that you should go enable TLS 1.3 across an environment that is legacy, that's got operational technology, it's going to fucking break everything. Or if you enable SMB signing, where SMB signing maybe isn't applicable, understanding how that's put together makes your life a lot easier. This guy's given up. He's like, this is shit. So, and ultimately, when you have these four pieces, you have a better understanding of collaboration, which is the purple element of things, where you've got red and blue. If you can understand how things are built, how they're broken, and how to defend against them, you can collaborate between the different teams. So, my lab setup. This is a very simple, I know the lecture's there, but this is a very simple setup. I essentially have two machines in my lab currently, and this is a telemetry lab, so it's built essentially for gathering telemetry. And I built it to understand how noisy Windows environments can be. So I've got a workstation which is running Defender for Endpoint, and I've got a domain controller which is running Defender for Endpoint and Defender for Identity. The reason I picked that EDR is because it's relatively cheap. Anyone can pick up an E5 license. They are, off the top of my head, I think it's about £6 a seat per month. So like 60 quid a year for an MD license is a bargain. Anyone can sign up for an Azure subscription, and as a result, you can have MDE. And MDI is similar pricing. The way that the setup for MDI works is essentially you enable a bunch of logging on DC and the endpoint, and then you essentially deploy it. On my GitHub, I've got a Ludus config for setting up MDE MDI if you want to do that. So I've set these two up. In the DC also has a certificate authority, so anyone who's exploited Active Directory certificate services, there are a myriad of different files within there. Now, these two boxes feed into the cloud, which then have access to the Advanced Hunting Interface, which is KQL, which then goes to the SOC analyst, which is me, and then that feeds into protection. On the endpoint itself, this is what the operator touches, the red team, we've got lots of kind of monitoring. So we've got Sysbon deployed. I've already talked about these two. And we've also got DNS logs, and then we've also got security logs turned on, and additional EDR telemetry. So I've got an ELK stack set up in addition. So I'm basically set up these boxes because I wanted to see, first of all, how noisy Windows was, like from a baseline, and then also how to effectively monitor what normal looks like. So then when I do malicious stuff, what does malicious stuff look like? And when I talk about malicious stuff, I'm not talking about dropping like malware.exe on this. I'm talking about using like letting off the land binders and scripts. And I'll talk about that a little bit later on about how logins aren't always, or logback, they aren't always as stealthy as you might think, because if the environment, that's fucked.
That's not a problem.
There we go.
You just pour beer over yourself.
There we go. If the environment doesn't have lol bins in place, then it's going to look out of place. I don't know why this keeps dying, but alas. So that's the lab setup. The build, break, defend, fix methodology. So what we've got is we've essentially got Bastion, which is the workstation, and Citadel, which is the domain controller, and all sorts of logging goes into different places. From the workstation specifically, essentially it's got telemetry turned up to 11. I have got Sysbon deployed on both. Specifically for Sysbon, the reason that I deployed it is I didn't deploy it in detection mode. I deployed it in just observability mode because I wanted to snarfle up as much logs as possible. So I've got EID3 feeding in, EID0, EID1, EID7, lots of basically everything that isn't prevention for Sysbon is turned on for Sysbon, and as a result, the logs that I've got going into an ELK stack are in the gigabytes an hour, which, as you can imagine, anyone who's worked in SOC is quite a lot of logs. And what I did with that information is I then fed it into a local LLM to parse all that data. Because I don't know about you, going through multiple terabytes of logs is fucking horrible. But having an LLM do it for me is much easier. And what I pulled out of that was understanding, it gave me a lot of insight into, first of all, how to deploy logging onto an endpoint. Because anyone who's ever looked at deploying logging in Windows, it's a bit painful. Out the box, Windows doesn't have audit logging turned on. It doesn't have specific things on the DC turned on for Kerberos. If you've got a certificate authority in place, it doesn't have that logging turned on. So if you're doing, from a red team perspective, if you're doing like ADCS attacks, Active Directory Certificate Services, that isn't logged by default unless you've got an EDR in place which is doing stuff. So enabling those additional logs allows you to essentially get that information. And then the way that EDRs work, or the way a lot of EDRs work, is they essentially collate all of the data together and then they base it on behavioral detections. Now, every EDR is different. From what I've learned about MDE essentially profiles it based off of the complexity of what the chain is. So if you're going from SVC host to PowerShell to something else to something else to something, that looks suspicious even if it's not suspicious stuff you're doing. Or if you're going from an application, that's going to die again. If you're going for an application that is not normally launching command prompt, for example, if you're using like macros, that also looks suspicious, even if you're doing benign. I'm going to look terrible on pictures, by the way. I just look like Peppy Sylvia explaining stuff. Much like Saskia looks like a gargoyle when she's presenting.
Oh. Just pose now. Get the photos.
Oh, you have to say, take the photo.
Take the photo. No, anyway, it's fine. So as a result, Saskia's not a gargoyle. She's a wonderful person. As a result, you get all that information and you understand how these things are put together. And from an ADCS perspective, specifically, the reason I talk about ADCS is it's probably one of the most common attack paths in a Windows Active Directory environment if there's a certificate authority in place, because for ultimately, anyone who's not aware of it, you can go from a low-tier user, so domain user, with the ability to enroll a certificate on behalf of a higher tier user. So you can become domain admin within a couple of minutes, which is obviously pretty bad. So native doesn't always mean invisible. This is what I was talking about, process trees and things. Ultimately, if you're looking at a box, just ignore the context for the moment. But if you're operating from a box, an Explorer launches command prompt, which then launches who am I. For the most part, that's pretty benign because it's standard behavior. It's what you chain onto that looks suspicious. So if you're, for example, a non-sysadmin user, if you're finance, if you're even in engineering, if you're in development, and you start creating who's in the domain admins group, you might think, oh, I'm using the net command, that's built in, but in actual fact, that looks really suspicious because why does a developer want to know who the domain admins are, or the enterprise admins, or the exchange admins, or looking at certificate templates that are available? This is the other thing I've learned from kind of looking at logs is that if you look at if you take a tool like Certify, for example, which is an ADCS tool for requesting certificate templates, Certify on its own is not malicious. It's the different commands that are built into Certify that cause it to flag alerts. If you run the Certify find command, which is searching for available certificate templates, it doesn't filter for vulnerable to start with, just all certificate templates. That specific LDAP query pings off MDI because MDI looks at it and says this is reconnaissance on certificate templates. The way you would do it in a stealthy manner is you would request specific templates. So you would say, I want all of Active Directory first, and then I want to go into the PKI services, and I want to look at those specific templates. Same way that you would do with Kerberoasting. The way that Kerberoasting gets caught in environments is Kerberoasting, for the most part, any kind of identity software will catch it when you do a query for all service principal names, SPNs. Whereas if you query specific SPNs, if you query for specifically like AES versus RC4, if you look for AES, it's less suspicious than RC4 because RC4 is a downgrade attack and therefore is flagged as malicious. Similarly, from a Windows Word environment, anyone who knows anything knows that the second command looks suspicious as fuck because you're running encoded PowerShell, right? For the most part, encoded PowerShell should never be run in an environment. There are sometimes setups that use this kind of stuff, but if it is, you can ask afterwards. You're not. Wait till the end. And there's plenty of time. I know that some Defender does do it all the time, but that's anyway, going off tangent. Fucking love tangents. These things look malicious. So understanding that when you're living off the land and not dying in the detections, this is essentially a legitimate binary, a legitimate command, but it's unusual context. So if you're running this command from a machine that is not used by an admin, it's not a domain controller, it's nothing that should be running this command, even if you don't have an EDR on the endpoint, it should look fucking suspicious, because who in their right mind is checking... Who in their right mind's checking who domain admins are? Ultimately, LawBass only work if it belongs there. It's the same way with downloading things onto endpoints. If you're doing like invoke web request on a machine that doesn't normally have that type of stuff, I've used finance as an example. So finance typically use things like Excel, they use things like SAP, they use Word, they use a browser, they probably don't use PowerShell. Now, granted, there are some accountancy departments that do use PowerShell, but they're certainly not going to be downloading things with invoke web requests, or if they are, it might be specific to that environment, but for the most part, they're not going to be doing that. The other things to think about when it comes to LawBass is looking at what you've actually got installed on the endpoint. If you're working with a hardened environment that has like a very good baseline, that has things like CertUtil is disabled, Windows Management Console is disabled, there's not RSAT, so remote server administration. Have you got something to say? No, it's fine. It's not got remote. No, it's fine. It's got remote server. It doesn't have remote server administration tools. It doesn't have all these things. But that might be present on a server, and it might be more beneficial to run that from a server than it would be to run on a workstation. So these are all things to consider. The other thing to consider around LawBass as well is looking for binaries that are maybe not Windows binaries. So a lot of the stuff in LawBass, they are Windows binaries. But what I like to do in my free time, when I have free time, is look at what applications are installed by default in enterprise environments and understand what those things ship with. So a good example is VMware tools. Anyone who has an ESXi stack or vCenter will probably understand, or maybe not understand, that VMware tools, any VM that you deploy in an environment has VMware tools because you require it for interacting with the VM. Now, VMware tools ships with Python by default. It ships with 7-zip by default. It ships with, I'm pretty sure it now ships with curl as well by default, which is an outdated version, which allows you to circumvent application allow listing. This is, in hardened environments, very difficult to bypass in instances whereby you've only got a set amount of binaries you can execute. But if you know that VMware tools are in the box, you can go, all right, cool, I've got 7-zip, so I can bring tools in and out of the environment. I've got Python, so I can bring any .py file in and run it from that directory. A lot of the time, the standard user will have write access to that directory as well. So if you've got malicious scripts, don't call them malicious.py, call them, diagnostics.py. And anyone who's ever looked at diagnostics from a defensive perspective will understand that they look really malicious, but a lot of the time they're legitimate. But if you can blend into that noise by running diagnostic commands, which are also build review commands, you get a lot of information at the endpoint without doing anything overtly malicious. And if you're thinking like a red teamer, thinking like an adversary, understanding how to act like a sysadmin means that you blend in much better. Things like AD Explorer. AD Explorer is, I don't think I've used Bloodhound in an environment in about 18 months, 2 years, because AD Explorer is so great. AD Explorer is a sysinternals tool which is signed by Microsoft and takes a snapshot of Active Directory. You download it, it's a portable binary, it's written in C++. It will essentially allow you to connect to a domain controller with a username and password. It's domain user domain password. Doesn't need any special privileges to run. And then once you connect to Active Directory, you've essentially got RSAT, so remote server administration tools, in the palm of your hand. You can use it. What it also doubles up as is you can take what's called a snapshot of Active Directory. And by taking a snapshot, there's a couple of IOCs from that, but you have a snapshot which creates a .dat file on disk. And with that .dat file, there are tools out there which will allow you to extract all of the relevant data and put it into Bloodhound. There's an AD Explorer snapshot.py to Bloodhound converter, which gives you most of the useful stuff out of most of the useful stuff out of Active Directory in Bloodhound format, which means that you're no longer looking at a list of like users, groups, OUs, and you're now looking at a graph view of what you can access. The IOCs that come with AD Explorer, there's a couple. The first one is the .dat file has a specific header in it. So when that file is written to disk, it's always got the same header that tells you that it's AD Explorer, because it means that you can load it back into AD Explorer. Now, one of the ways that you can circumvent things like MDE and other EDRs is you can modify and kind of change that signature. So be it you write that to like a file share, for example, rather than writing it to the direct disk. Or if you've got it in memory in a beacon, you can kind of corrupt the file and then you can rebuild it off disk. One of the other IOCs, bit more difficult to modify, is when you run any sysinternals tool. It doesn't need to be AD Explorer. It can be like Procmon, it can be Process Explorer, it can be PSExec. They all set a EULA, so you need to accept the EULA, which is the terms and conditions before you run these tools. When you click accept, that creates a registry key on the box. Now, a lot of defensive tools, not just EDR products, a lot of logging tools will flag that registry key has been set. Now, the way that you blend into environments, what I tend to do first when I land in a box is I'll look at what shares are mapped to the box. I'll then look at what tools are in those shares, and then if I can find sysinternals tools, I know that AD Explorer is going to be safe, because there's likely an exception for AD Explorer being run. Not just the execution of the binary, but the typical IOCs that it writes. Like that registry key being written will be used by lots of people because it's in a share, it's probably going to be used by IT, therefore it's more likely to blend in. The other things I look for in shares is scripts. Now, a lot of the time, this is kind of nothing new. A lot of the time in scripts you have like things like credentials. Credentials are great, but the thing I look for is what those credentials connect to, because then I want to find out what those boxes have access to. Things that I have found that I go after more frequently nowadays is looking at database connection strings and looking at what privileges those databases run as, because a lot of the time, anyone who's ever done certain exams, I'm not going to name the authority, but anyone who's done certain exams will know that one of the kind of common exploits in a database is XP command shell. XP command shell is an MS SQL function that allows you to execute commands under the database process. Sorry, I thought it was a child crawling in. It's just Chloe.
And you're terrified of children.
I am terrified. I mean, Scott's got one in the lead. It's like a dog.
Careful.
I'm not calling his kid a dog. I just think anyway.
Big up, Stu.
Yeah. I'll keep digging. Ultimately, when you get into database, you can execute commands onto that database. A lot of the time, it doesn't look suspicious because if you've got common things that are being executed on that database, maybe it's querying things like server infrastructure or it's an asset list or something similar. That's another thing I look for is asset lists. It looks less suspicious. Asset lists are something that's incredibly useful to red team, blue team, and anyone and adversaries combined. If you've got an asset list on a share, that gives me immediate reconnaissance data. I don't need to look at your environment. If I know where your servers live, if I know where your databases live, if I know that you've got SCCM in the environment, which is essentially what's used to push software to the endpoint, I know immediately that I've got privilege escalation opportunities. I know that you might have a certificate authority. I know where the certificate authority lives. If you're nice enough, you might have your certificate templates as well listed, so I can query for those names as well. These are all things that I look for. In addition, this is not necessarily relevant to this command. I forgot to say this, I go off on tangents, but in addition, one of the other things I look for is design documentation. So everyone who's ever done architecture has probably written design documentation. Everyone who's ever been a pen tester has probably looked at design documentation when you've done a build review or something similar. The key things in design documentation is understanding where the security boundary exists in different software. I've done a lot of work throughout my career for large organizations, and I've reverse engineered a lot of interesting tools. But the reason that I've reverse engineered them and found interesting things from them is reading design documentation, because understanding that the security boundary exists for here and the master key exists over here, if I can reverse engineer this master key, it makes me breach the security boundary. And that's not doing any hacking stuff. That's living off the land by the sole definition of living off the land. So, environment. This is the environment that I've got set up. This is another environment I've got set up. I'm going to talk about processes and ports and networking. I realise this is probably quite difficult to read, but essentially what we've got here is we've got a workstation, an attacker machine, which is connected over the internet via, HTTPS, SMB, and it's also got RDP access. We've also got in the environment a domain controller and a file server. Now, the common things that are connected to between these different hosts, the workstation talks to the file server, typically over SMB because you're accessing shares. The workstation connects to the DC over DNS because you need to look up hosts. It connects over Kerberos because you need to authenticate. It connects over NTP because it needs to get the time. Or it might connect to an NTP server. If you've got an NTP server, most of the time it takes in the DC. You've got remote procedure calls for specific services. So like if you're authenticating, if you've got MDE on the box, it uses RPC to talk to different entities and also talks to the cloud. You've got LDAP and LDAP-S. LDAP is 389. These are all tips for if you're doing the 8 out of 10 hackers later on. There is a ports quiz, so maybe take some notes. You've also got LDAP-S, which is 636. It's basically TLX interrupt LDAP. And then you've also got SMB, and then you've got the global catalog as well. Global catalog is less used, but global catalog is used for things like mapping printers. It's used for things like mapping Outlook groups and things that are similar to that. Similarly, from the file server, you've got most of those things as well, and the reason this is important is as an attacker in the environment, when you are running different tools, maybe you've got a beacon, you want to be cognizant of what processes you're injected into and what ports those processes talk to. If you're injected to, I don't know, Word, for example, if you're running a beacon in msword.exe and you start doing Kerberos activity, you start doing SMB activity, straight away, as a defender, I'm like, what the fuck is Word doing speaking to Kerberos and SMB and all these things? That's why it's really important. That's why it's really important to understand what normal looks like. Similarly, in this context specifically, if you want to connect to the DC, for example, and maybe the workstation isn't connected to the domain controller, maybe for whatever reason it's in a separated network, so just think for a second, this doesn't exist. You might want to go through the file server. So you comprise the file server and you find that on the file server there is rsync running. And rsync is essentially a tool for backup. That talks SMB, that talks Kerberos, that talks a lot of other things. And I've got a demo in a couple of slides which is offline and live, and I'll walk through process lists and explain how the different kind of frequency of ports exist. So, understanding your user, understanding your environment. Here we've got 3 different profiles of 3 different users, and we've got time telemetry as well. At the top we've got finance, developer, and sysadmin. Finance typically use Excel, use SAP, developers probably have VS Code, sysadmins have PowerShell and RSAT and MMC. That goes to our advantage as a red team, because if we understand what these users are using, we can start to use the alternate functions of these things. For example, Excel has the ability to run XLL files. XLL files are essentially executables within Excel. So you can run things like macros, you can launch command prompt from within Excel legitimately, and it looks like it's running as Excel. Now, Excel isn't spawning an external process, it's spawning it as a child process as legitimate activity. Likewise, SAP, horrible application, but has lots of functions built into it. If you get the ability to run as an administrator on SAP, it has a command interface that allows you to connect out over Kerberos, so you can inject into SAP and Kerberos from SAP, and it doesn't look as suspicious as it would do coming from Word or something similar. How am I doing for time? Have I got 1 minute? Fuck, right, okay. So, basically, observability is great. Why did you not give me the 5 minute? There was meant to be a 5 minute 5 minutes ago. No, it was.
You kind of need the person to see it, acknowledge that.
Yeah. Fuck, right. Who's after me? Is it lunch?
No, it's Katie.
Oh, bollocks, right, fuck.
She's going to kill you.
Right.
No pressure, but she's going to kill you.
Excellent. I mean, fuck it, it's fine. We've now got 30 seconds to go. Maybe. Yeah, so blending in, we've got search filter. These are things that made memes. Memes are funny. Yeah. If I can instill anything upon you that you've taken away from this, use it. So RMMs, remote management tools. Use the ones that are built in. SCCM, Intune, and if you can get EDR, interactive access, so live response, RPR, there's other things, you can use them to your advantage because they give you command control built into the box. SCCM allows you to get a shell, you can push things to the endpoint. Intune allows you to push things to the endpoint as well. So great red teams understand telemetry, great blue teams understand tradecraft. I've been Andy Gill. Thanks for listening. If anyone wants to learn more about what I do, I've written a course on red teaming. It's on this URL here. You can use this code and get 10% off. The course is £349 normally. 10% gives you £300. It brings it into about £315. The course is centred around learning malwareless adversarial emulation, so it's very much operating about the stuff we talked about. If you're more interested in the specific baseline of Windows, I've wrote a blog post a couple of weeks ago, which is there. And if you need to find me on the internet, I'm Zephyrfish. I'm 2 minutes over. I'm sorry, Katie. Thanks, everyone.